Yeah, good day, everyone, and welcome to today's training session. This is to officially welcome each and everyone to this very session of our training solar power system installations. This is again to welcome each and everyone to this live class, to the very first live session of this course, Basic Solar Power System Installations. Yes, it is a course on basic solar power system installations, and the course commenced some days ago, should I say yesterday, and we have been able to walk everyone who joined us for that session on WhatsApp or via WhatsApp what we are actually talking about when we talk about solar system, solar power system. Just to have a recap of what we have done so far, so good. We said that solar energy is the energy gotten through the sun when one of the solar component absorbs the rays of the sun and converts it to electricity for us to use in our facility, which may be your company, your shop, your house, anywhere you want to power up. Then there are two types of solar power system. We have the one we call the on-grid. We have the one we call the off-grid. We categorically explain that the on-grid type of solar power system has to do with you being able to have electricity in your facility all day, all time, all day round, right? Due to the fact that you will be connecting to more than one power supply source at a time. Yes, you'll be connecting to more than one power supply source at a time. And that simply means or tells you that you have access to the solar system, which is the energy from the sun, which is connecting to your solar panel or generating energy with your solar panel. You are also going to be connecting to the grid or your generator or any other power supply source just to serve as a backup system. Then, when you talk about the off grid, it means that you are only going to have access to one type of power supply source at a time, and in this case, it is going to be solar. We introduce the various solar components. Basically, there are four types of solar components used: the inverter system, the solar panel, the solar battery, and the solar charge controllers. We didn't also leave out or forget the safety tools and gadgets like we always say. Safety is of great importance when we talk about solar system installations. We talk about things like your breakers, your fuse, your surge, your earthing, your changeovers, okay, either the manual changeover or the automatic changeovers, which aids you or with the flexibility of switching between two or more power supply sources. We also went ahead to tell you other things that you need to know. Uh, safety measures to take as it concerns your solar power system. Do's and don'ts as it concerns your solar power system, and a few other maintenance culture which you will also be walked through as you continue and progress in this training. We also talked about the types of battery connections, which has to do with the series, the parallel, and the series parallel. We then rounded up by giving a basic knowledge of system installation. A lot of questions were taken on that very platform, and then a lot of answers were also provided. Yes, that was how that training went down. Before we dive into what we have for today, we observed that some persons had questions to ask after we had rounded up the training session that day. So we want to give those people that opportunity to ask those questions before we dive into what we have today. As long as it is within the framework of what we have done before, you are allowed to ask the question. Again, as long as it is within the framework of what has been done previously, you have the opportunity to ask those kind of questions. Those questions you definitely be allowed to ask. So please, right now, this is the procedure. You speak from a quiet background, please, not a noisy place. You speak from a quiet background, not a place that will disrupt the activities of this class. If you are in a noisy place, please use the chat box to talk to us. There's a chat box in here, which you can type your messages. We'll read it aloud and answer it accordingly too as well. And then, secondly, you tell us your name and your location. Those are the principal things you need to tell us. Those are standards of our training platform. All right, quickly, let's take a few questions, two or three questions before we hit the road to today's training session. So if you have questions that is related to what we have done before, please let it be related to solar, that is one. Two, let it be related to what we have done before. So if you know you have not studied what we have done before, don't bother asking questions because they will not be answered. All right, let's go, please. If there are any questions, you can throw it in now, please.
Good evening, sir. This is
Yes.
Collins. I'm Collins. For signing yesterday, I am studying what we study yesterday. I was glad you said that some solar charge controller help the help for easy connection of DC load. That you can connect your DC load in charge controller. Um, I'm talking about if you are using hybrid inverter. Where can you connect your DC load? Is it in the PV input? Is where you can connect your DC load? That place that you think that place that you can connect your PV input. Is it that place that you will connect your DC load that is provided the state? Because you say that if you connect it to the battery, it will also drain the battery quickly. But if you connect it direct to the charge controller, if you are using charge controller, that it will help. Is that it will powering it by the solar panel will be powering it. So if you are using hybrid inverter that is not contain charge controller, so where can you connect it to this? Is it from the PV input,
Okay,
please,
sir.
sir?
Okay, sir. Thank you for that question. So, Mr. Collins, you left out something. You didn't tell us your location. Where are you joining us from, sir? Are you in Nigeria here with us?
Yes, sir. I'm from Nigeria, Enugu State, sir.
All right. Okay. Okay. So now your question is a very good one. It is good that you already have idea of what we're talking about here, because for you to mention the hybrid system, it shows that you already have a fair idea of what we're talking about here. So the hybrid inverter system is that which gives you the flexibility of having multi functions, or a system that has multi-function in a single unit. Okay, so it means that your hybrid inverter system has the charge controller installed in it. It has a charge controller installed in it. And having the charge controller being installed in it simply means that you are not expected to use an external charge controller except in special cases. So you may wish to ask, what are those special cases? We will not discuss it now, but as the need arises, we may discuss it as the training progresses. Okay, so in the case that you need an external charge controller, you may make use of it. But if you are using a hybrid inverter system that agrees with your system design, you don't need an external charge controller. That is one explanation, an additional explanation that you need. Now, back to your question, how do you power up your DC loads? You may not be able to power up your DC load when you are using a hybrid inverter system, because most hybrid inverter systems do not allow you or do not give you the option of powering DC loads directly from them. Okay, yes. So when we said power up your DC loads from your charge controller, it means that it has to be an external charge controller. Okay, so it has to be an external charge controller. It also has to be an ordinary inverter system, not hybrid. It has to be another inverter system, not hybrid, sir. So I hope you now understand what we mean by that. You just need to power up your DC loads directly from your charge controller, because your hybrid inverter system might not give you that option of powering DC loads. Mr. Collins, I hope you understand that now, sir.
Yes, sir, I understand it, sir. Thank you, sir.
You're welcome. All right, we can take one more question if there are any. Kindly talk to us. Okay, Mr. Nelson is asking a question. Mr. Nelson is saying, um, okay, uh, Mr. Nelson, Mr. Nelson is from Nairobi and is asking a question on the cable sizing. Mr. Nelson, you did not go through the whole messages that was dropped on the platform yesterday, so we'll refer you back to it because this question has already been answered. Okay, on cable sizing, it has already been answered. So please go back to that message, go back to the question. You will see the answer there. All right, Mr. I saw a hand up right now. Is it Cabo? Is it a man? Is it Mr. Cabo or something? Please, you can ask the question you want to ask if you have a question. I saw a hand up right now. Okay, so is there anyone who has a question to ask? No one has a question. All right. So Mr. Nelson, our friend from Kenya. So this your question on cable sizing, like we answered it rightly in the last class. We said that this is the basic solar system installation course. Okay. Cable sizing has a whole lot of things to do with it. That simply means that it has a high volume, or it is a voluminous in nature, such that we cannot just dive into it and finish it up like that. There are so many things to consider: voltage drop, ripples along the line, your system parameters, your IMP, your VMP, your length of transmission is also there. And then we also make use of voltage online voltage calculators to design your various cable sizing between your battery and your inverter or your charge controller, between the cable size between your charge controller and your battery, between your battery and your inverter system, or even the cable sizing from your output of your inverter to your load, which is your AC cables. So we said for this basic course, we removed it and then put it into the advanced course. So it means that for you to have step-by-step designs of your cables, you need to enroll for the advanced course. But then you don't need to panic, sir. You don't need to panic, because for this basic course, we know you'll be making use of cables for your installation, because after this class, you must try your hands on some project before you can now say, okay, you are moving on perfectly, and at that same time you can enroll for the advanced course. We have also packaged that cable sizing in such a way that we only give you the summarized ways of getting these various sizes, and we put it into the manual. So it is rightly hidden inside the manual. Okay, and that was why we said, for those who have made their payment, we will send out these manuals to them, and then they will have access to this other information that we will not be able to give out in these live classes. All right. So after this class, we will start sending out the manuals. We have sent out some badge before, and then we are going to send other badges. We are sending it badge by badge. So immediately after this class, we will send out some other badges. So make sure you must have paid the enrollment fees by then, so that you will also receive that manual and then have the information that you want to have. Mr. Nelson, that information is for you. I hope you have heard me loud and clear. Okay, I believe you have heard that. So we can proceed. Hello, everyone. Can you all hear me clearly?
Yes, sir.
Okay. Okay. So Mr. David from Sierra Leone is saying he's a beginner. we should consider beginners and then take the course as beginners. Yes, this is a beginner course. This is a beginner's course, so that is why we call it the basic course. In as much as it is not entirely beginners, but then we take it as easy as possible to the barest minimum, so that if you're a new person in this field, like myself, I'm a new person too, like you, Mr. David. So we are both new, we are both beginners, okay? All right. So we take it easy with one another, but then you must make sure you follow up, ask questions, study the materials, pay your enrollment fees so that you too will be held by the hand to take these baby steps with us. I hope that is clear, Mr. David. Thank you so much, sir. Thank you. So, after we had already summarized everything we have done in the past and taken some questions, yes, we can now say that we would have to move ahead. Now, usually, at the end of every class on WhatsApp, there is one particular question that always come up. What is this question? How do you know the size of inverter system suitable to power up your one room apartment? How do you know the size of battery system that will run that inverter system? How do you know the size of solar panel which will power up that your facility as well and recharge your batteries? And we kept on saying that it is almost impossible for anyone to give you that information. Not that it's impossible because we do not know how to give that information, no, but because you really need to have a basic idea of what to do, basic idea of the standard parameters, standard conditions which you need to put into consideration before you can talk about the various sizes of your solar component. That is how we arrived at today's lecture. So, this class or lecture is to walk us through the process of what we call energy audit. I hope we are all together. Mr. Nelson, there is a noise from your background. Please mute yourself, sir. I hope
Okay,
we are
okay.
I hope we are all together. Please, if at any point you don't get to see my screen or you don't get to see what I'm sharing, please let me know. Once again, this is a live class. It has to be very interactive. You must see what I'm sharing on my screen so as to be able to follow up. Mr. David, who is a new person like me in this field, please, at every point in time that you lose my screen, please let me know. Okay. And again, this class is being
I know that screen, sir. I know they see you, sir.
don't worry about me. Don't worry about me. Just focus on the screen for now, sir. I'll be giving out the information, okay? At least you can hear my voice, but the screen has also other information you will need to relate to it. So when you eventually enroll for the advanced class, by then you will then see me. Thank you so much for that. So, what were we discussing? Energy audit. We said that there are things you need to put into consideration before you can say that this is the size of inverter system that is suitable to power up a facility. Okay, so when we talk about energy audit is in two categories. One, it helps you to take care of the energy need of a facility. That is to say, you have to have idea of what you are powering up, and then the various information of the various appliances that are to be powered up using that your solar system. Then, when we say you have to know the energy need of the facility, it means that how much energy are those things consuming in what? So, when you have information of this energy need, you then use it to size your various solar components. That is what we are talking about. So I simply mean that before you can say, so let's say Mr. Collins is a client of ours for tonight class. Let's say Mr. Collins is now asking us that oh, he wants to install a solar system in his facility, we will not just go ahead um, to give him any solar system. No, we firstly have to know, what does Mr. Collins intend to power up using that solar system he wants to have in his facility? What does he intend to power up? Mr. Collins might want to power up 10 air conditioners, 5 freezers, 10 microwaves, and we are bringing 2 kVA to him. That cannot work. So if Mr. Collins is able to give us the various appliances he wants to power up, then we will know the wattage, the total wattage of those appliances, and then use that information to size the various solar components. All right, I'm going to share my screen right now. Please kindly signify, can you see my screen? Can you see what I'm sharing? Okay, Mr. David, what
Sir.
can you see on the screen, Mr. David? Mr. Collins, what can you see on the screen?
I see energy auditing. Auditing is the documentation of the energy
Thank
requirement
you.
for
All right.
building.
All right. All right. That's okay. That's okay, sir. That's okay, sir.
It
Thank
is a
you.
careful examination of the electrical loads.
That's okay, Mr. Collins. Thank you, sir. Right. All right. Thank you. David, you can mute yourself, please. All right. Okay. So, yes, energy audit it is. Energy audit is what you expected to see on my screen. Please, if you're not seeing energy audit, it means that there is something wrong with your network connectivity. Log out and log in again. You will then see it properly, like Mr. Collins can see it. So, energy audit, like I have said before, does two things for you. It helps you to know the energy need of your facility, which is the wattage that those your appliances are going to consume, and then you use that information of the energy need to size your various solar components. That is why you can see on my screen that energy audit is the determination of the energy requirement for a building. It is a careful examination of all the electrical loads. When we say electrical loads, it means that those are the appliances that are to be powered up. Those are your freezers, your air conditioners, your microwaves, your TV, your fan, anything that you need to power up using the solar system are your electrical loads. Anything that you power up with your electricity is your electrical load. So, energy audit helps you prevent oversizing of your system. It helps you to prevent oversizing of your system, safeguarding your electrical appliances from damaging from inappropriate power surge, and then generally saves you cost. Now, there are three things that energy audit does for you here, in as much as there are other things it will do for you, but we have just brought out three specific things it is going to do for you. Three specific things it is going to do for you. One, it will help you to prevent oversizing of your system. Two, it will give you safety and security to your system. Three, it will also save you costs. Firstly, let us analyze how it prevents oversizing of the system and then relate it to how it saves you cost. Then, on the long run, we will talk about how it also gives you safety and security to your solar system. Please give us thumbs up if you can hear me. Give me a thumbs up. Use your favorite emoji. Let me know you can hear me correctly.
I hear you,
Thank you
sir.
so much. All right, thank you. So, now, talking about how it prevents oversizing of the solar system, it simply means that when our client for tonight, Mr. Collins, has invited us to run a solar system for him, or he calls us with our number and says, "Oh, Vatfield Tech, please, I need a solar system in my house." Then, as professionals that we are in this field, we are expected to know what Mr. Collins intends to power up and not assume a certain value or amount of load. or just say, okay, we have 15 kVA. Would you like us to install 15 kVA for you? No, that is not done. So let's even say that Mr. Collins calls us and says, okay, he needs a stable power supply in his facility, something that will power up his house. Okay, we'll say, okay, Mr. Collins, how much do you have? Mr. Collins will say, okay, 15 million. Oh, we'll say, very good. Let us give you 15 kVA with 24 units of 650-watt solar panel with a 20 kilowatt hour battery backup system, and then we will also bring all those big systems for him to store for him in his facility. Have we done the job we're contracted to do? Yes. But have we done it the right way, the proper way, professionally? No, we didn't do a professional job. Why? Because we didn't take the energy audit for that facility. We did not know what Mr. Collins intends to power up. So giving him a solar system will provide him steady power supply. That is quite all right. That is fantastic. That is beautiful, right? But then we really need to know the things that he intends to power up, so that we do not give him a too large system or a too small system. Then connecting it to how it saves you cost simply means that if we carried out a proper energy audit on that facility and we see that he intends to power up basic loads and which does not consume more than 2000 watts, which means a 3.5 kVA should be enough and can run on a 5 kilowatt hour lithium battery, and a 6 unit of 500 watts is already perfect for that installation. That means that when we got a 15 kVA, 5 kVA can do it. You know that the cost for a 15 kVA is never at the same level with a 5 kVA system. That is what energy audit is trying to tell you here. So at every point in time, when a client wants to go solar, please, when a client wants to go solar, it means that one, he wants to have energy independence, right? Yes. Two, he wants to cut cost on electricity. Three, he wants to have convenience of power supply. So when you put all of these things together, you should always do a proper system design. And again, whenever we talk about energy audit, it's all about talking about system designs. So a client can even call you and say, oh, Mr. Collins, please, can you design a system for me? Yes, you can, by going through the process of energy audit. So, in summary, energy audit links the energy needs of a facility to the sizing of your various solar components required for that your system setup. That is the second part I have been talking about. That is to say, you know what you intend to power up, and you use that information of what you intend to power up to size your various solar components. That is what that one simply tells you. Okay, things to consider during solar energy audit. One, the list of electrical appliances to be powered by the solar system, the power rating of the electrical appliances in watts, daily running hours of the appliances, total energy consumption of the building, total energy consumption of the building, and that is the four things you need to put into consideration. Yes, these are actually the parameters that you need to know, that you need to have a very good idea of for you to run a good solar system setup. All right. At this point in time, you may relax a bit from it, because as we progress in tonight's class, we will definitely dive deep into it and give you all the in-depth knowledge of all of these things. Okay. But for now, hold it close to your heart. So, thing wait, hold on. That is not supposed to happen. So now we talk about safety as it concerns your solar power system. Remember, we said even your energy audit ensures safety, which means that you also need to size properly your safety tools and gadgets. You need to size your safety tools and gadgets. Okay, so in sizing these your safety tools and gadgets, it simply means that safety in solar system is keeping the entire solar system and your home appliances safe for use. It keeps your solar system and your home appliances safe for use. So now, this is the rainy season here in Nigeria, and the rain these days comes with a whole lot of thunder strike. Okay, but the interesting thing that we need to know as professionals in this field is that it is not actually the thunder strike that damages your system, okay, that causes problems in your facility. No, a client will call and say, "Vatfield Tech, after the heavy rain, we heard a loud sound, which was the thunder strike. And at that moment in time, this inverter shut down and then it refused to work." And then some professionals in the field or some installers in the field will tell their client once there is a drop of rain on the roof, they should just turn off the inverter quickly. I don't know. I don't know if anyone has experienced that before. Or anyone has heard that before. Once the rain starts falling, turn off your inverter quickly. so, so please, it is good that you turn off your inverter system when it is raining. That is good. That is correct. However, it is not. Um, it is not uh, a good system setup that has been done for you if you have to turn off your system when it is just little showers. All right. So what actually causes damage to your system is lightning and not the thunder strike. The thunder strike is just a noise which accompanies the lightning. The lightning effect or are charges in volts, very high voltages. Yes, if it hits someone in an open space, that person will really be dealt with. So your solar panels are in the open space, and they are the ones that are very close to this danger. Okay, so when you have that lightning strike, excess energy will be absorbed by your solar panels. This is to tell you that even when there is no sun, the lightning strike can also generate energy for you. Yes. So when this your panels absorb this excess energy, it cannot hold it. It doesn't have anywhere to send it to. It will send it to your various solar components. And if these solar components are not rugged enough, they will be damaged immediately. That is what it is. That's what we're talking about here. So you need to protect it from all harm and protect yourself as well. I don't know if anyone has ever worked on an inverter after an installation has was done perfectly. You make a mistake and put a tester on the body of that inverter system, and you see that the inverter system, it has current on it. I don't know if anyone in this class has experienced that before. Most inverter systems, or let's not say most, so that we will not scare any one of us here. Some inverter system has that functionality that when it is not safely protected, it will have current on the body to tell you that this is not safe. And until you provide the appropriate safety measure, that is the only time you and that your system will be safe. That is the only time that system would say, okay, I wouldn't shock this my client, or I wouldn't shock this end user, or I wouldn't cause problems for this installer. I know you'll be wondering, how do you rectify such issues? Don't bother to ask, because that is a secret meant for those who pays for this training. Okay, so we so we also encourage you, because I know our client Mr. Collins has written it down now as one of the questions he wants to ask. so 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 please, you need to be enrolled before you have idea of this safety we are talking about. All right, in as much as that is that, we can actually give you real safety tips as it concerns your solar system. So your safe solar system is free from both human and natural disasters or hazards such as fire outbreak, overloading, overvoltage, undervoltage, lightning effect, and shock. Yes, these are the things that actually happen to your solar system. A few days ago, we posted a picture of a burning solar system, and we said we are going to post a video, a tutorial video uh concerning it. Okay, yes, we are going to do that. We haven't forgotten. We are definitely going to do that. And when we do, it is going to be available on our YouTube page. We'll just give you the link. You go there, you watch it. We also have other tutorial videos that are already available on our YouTube page. Interesting tutorial videos that will expose you to a whole lot of things: your inverter system, your battery system, your solar panels. It will give you in-depth knowledge of this field that you're into, and it is entirely free. Please, it's entirely free. Okay, so you just visit our YouTube page and watch all the videos that are there. I hope we are still together.
Yeah, very, very much. Yeah.
Thank
Yeah.
you. So these are your safety tools and gadgets that we've been talking about. These are your safety tools and gadgets. You have your MCBs, MCCBs, those are your breakers, right? You have your fuse, you have your surge, you have the changeover there, automatic changeover. You also have your PV box, your combiner box. So this is how it's expected to be. This is how it's expected to be. This is how you do your connections, all of these things you play with. This is how it is expected to be. You can see that earthing cable. It means that this system was well earthed. Okay, it means that this system was well earthed. All right, so we are done with the first phase of the lectures. We are done with the first phase of the lectures. And like we usually have it, this class is being recorded as we are here live right now. Okay, we understand the network connectivity issues we have all over Africa. We are all from Africa, we are all African brothers, right? And so we understand how these things work. So that is why this video is being recorded and is going to be made available as soon as we end this class on our YouTube channel. Just you go to our YouTube channel, you will see it. We'll also share the link once we upload it. So that is to tell you that you have nothing to worry about on our platform. So as we are live here and you face any challenge, please don't panic. Okay, just find a way to come back, join us, ask your questions, get your answers, and then you can seek for the videos at the end of the class. At the end of the class, you can seek for the videos. Okay, so we, like we said, we will always take questions mid session. Okay, we will take questions mid session. Please remember the rules. Your questions must be related to what we are doing presently, please. Yes, even though we will also allow you to share some experiences with us, but please let it be within the framework of what we are doing presently, so as not to uh go too far away from what we are doing and lose focus on what we are doing. Again, speak from a quiet background, okay? If you're in a noisy background, please use the chat box. Thirdly and lastly, tell us your name and your location. All right, so we can take 2 to 3 questions again at this point in time. Talk to us, please. Mr. Fabian, we can see a hand up. Unmute yourself and talk to us, please.
Okay, good evening, sir. Good evening, everyone. I'm talking from Nigeria, Ogun State precisely.
Okay.
So, actually, the question I want to ask is related. I've paid for a women's class, then I just want to ask that for that advanced class, can I play immediately so that I will know that I've paid for the class just for me to attend the training? Actually, I've put it in the chat box because we don't see anything about it. So then I want to ask that if I pay for that advanced class, will I get certificate after the class? So that's just my question, sir. Thank you.
Okay, I believe that you are Oyelami. That's you are a lady. Okay.
Yes, I'm a lady, sir. I'm a lady,
Okay.
sir.
All right. Okay. So we give ladies special treatment on our platform because it's not easy to have lady engineers. Most lady engineers we have always run away from doing hard work. So for your question on the advanced class is actually 20,000 naira for Nigerians. Yes, it's 20K, and then you get a separate certificate titled mini grid design, mini grid solar system designs. Yes, that's advanced certificate. Okay. Um, uh, like I said, we usually love female engineers, so you will be getting a discount, a special discount at that matter. Okay. So that you will also be encouraged to remain with us in this field. uh, and also you can also pay immediately. Yes, you can also pay immediately and then be doing the two classes side by side. So for being a female, for trusting in this process, for being in this field, you are allowed to pay 15,000 naira. I hope it is okay by you. All right, thank you so much. Thank you. You have the details, the account details already, so you can make the payment, send us the
Yes,
evidence
sir.
of payment, and then we can take it off from there.
Thank you, sir.
All right, you are welcome. You're welcome. Okay, so do we have any more questions to take before we proceed? Like one more question. The men will say we are now favoring ladies. They wouldn't want to talk to us again. uh, Mr. Collins, are you still here? Don't worry, guys. Don't worry, guys. Your time will come too. All right, Mr. Collins, do you have something to tell us before we proceed? Okay, so I think we should proceed. No one is talking. Your mic is muted, sir, if you are talking, Mr. Collins.
Okay, sir. Okay, sir. I know I'm pleased, sir. I want to ask small questions, sir.
Okay, go ahead. Let's hear the small question, please.
If you, is it must that all the inverter must have the earth space? Because one, I usually install hybrid inverter, but
Uh-huh.
the hybrid inverter that I am using have earth space. The space where the port where you connect your earth. If you
Uh-huh.
connect your earth, can you connect it from the surge? That is solar panel. That is the surge that I use to connect the earthing, the solar panel. That is you want to run the earthing, the your panel from the earth. Can you connect all of them before you send it to the ground, or you have the board that you connect each of them? I'm not understand, sir.
Well, you should have a board. In that your PV box, there is always a board which you have a central earthing system there. So you just connect all the earthing there and then take it to the ground. It is the same earth for all of them. As long as it is
You
active, as long as it is active,
okay?
it will protect the whole system.
Okay, you connect the earth spot from the inverter into the SPD of the in that say safety combiner board.
No, sir, I didn't say connect it to the SPD. I did not say that. I said connect. You have an earthing in your PV box. I don't know if you know what the PV box is. The kind one I showed you now. It has a space for earthing. From there, you connect to that port, and then you take it to the ground. Your SPD can also be connected there, but don't connect your inverter system to your XPD where you connected your solar panel. That's not what I asked you to do, sir.
But all of it to the ground.
All of them will go to the ground, sir.
Okay, sir. Thank you, sir.
All right. Okay, so we will have to proceed right now and proceeding. And in proceeding, we are now going to be talking about the deal of the day. I hope you all can still see my screen. I hope you can see my screen. Like I said before, if at any point you don't see my screen, please kindly call to my attention. Mr. Rabiu, do you have a question for us? If you have a question, now is your time to speak, please, quickly. I can see a hand up. Can you hear me clearly? Unmute yourself and talk to us. Okay, so I think that hand is in an error. Okay, so now we have to proceed. This is the point where you get to learn real system designs by having a proper idea of what we call electrical load analysis. Yes, this is that point where you get to learn what we call electrical load analysis. Remember initially, in the beginning of this class, we told you clearly that energy audit helps you to do what? Two things. It helps you to take care of the energy need of your facility, right? Yes, by telling you the amount of energy that is being consumed by that your facility as a result of the various appliances that are being powered up using the solar system. Then we didn't tell you how energy audit is to perform that duty. At this point in time, it is where you are going to be learning that how. So that how is dependent on this parameter we call electrical load analysis. Yes. So electrical load analysis is a calculation, series of calculations or processes of evaluating the energy needs of a facility. That is that is what the electrical load analysis does for you. It's a calculation, series of calculations or processes of evaluating the energy needs of a facility. So it means that for you to be able to know the energy that is being consumed by your facility, you must firstly know or have a very good idea of what you intend to power up. Like I have said earlier, you must have a very good idea of what you must have a very good idea of what you intend to power up. So that is what this energy audit does for you. That is what this energy audit does for you. In summary, electrical load analysis shows the exact wattage of a specific facility. Questions to be asked before carrying out electrical load analysis. At this point in time, it is worthy for you to also know that there are questions that you need to ask. There are critical questions that needs to be asked or that must be asked before you can say you want to carry out electrical load analysis on any facility. Yes, there are critical questions you must ask. One, energy need of the facility. Two, backup time of the solar system. And three, the budget for that your project. Yes, so those are basically the three questions you need to ask. Like we usually inform our students, two of these three questions are principal questions, while the last one is a supporting question which will actually help you to have a very good idea of the kind of system your client needs at that point in time. So let's take for instance again, Mr. Collins, who's our client for tonight, has invited us to run a solar system for him in his facility. On getting there, or while on still on the phone with Mr. Collins, the very first question we need to ask him is what is the energy need of his facility? What is the energy need of his facility? And at that point in time, Mr. Collins can now say or tell us. Okay, so asking Mr. Collins for the information of the energy need of the facility will then make Mr. Collins either he knows or he doesn't know. He will tell innocently he doesn't have idea of what you're talking about, and then you can break it down to him for him to have a better uh, idea of that information by telling him, okay, tell us the appliances he wants to power up. At that point in time, he cannot say he wants to power up his radio, his freezer, his microwave, his lighting point, his air conditioner. You will take note of all of those things, and then you'll perform some magic on it. Then you come back again and ask the second critical question by asking Mr. Collins his backup time. At this point in time, you need to pay more attention because this backup time is a standard parameter which plays a critical role in these system designs we are going into. When we talk about backup time, we are practically talking about the battery system. That is to say, um, you firstly know and understand the fact that the source of your solar energy is through the sun when the solar panels absorb the rays of the sun, right? Yes. You also know and understand that the sun does not stay up all day, which means that it has a time it rises, it has a time it sets, and it has a time to go to bed. So when the sun goes to sleep, it means that you might not have energy in your facility. But then, as humans, we will always have need for electricity at specific times of the day. So when you need that electricity at that point in time and there is no sun to give you energy, what do you do? That was how the battery system came to be. So some engineers came together to say, okay, we can build something that can hold energy for a length of time, right? Yes. So they included that battery system into it, and that was why when we introduced the battery system in the prelim stage of this course, we told you all clearly that that battery system was brought in as an act of backup. It means that during those periods that we will not have electricity in our facility, or during those periods that the solar panel will not generate electricity, we want to have power, which means we'll be depending on the battery system. Now, the question then comes in that how long can the energy stored in that battery system last for you in the absence of solar, which is a solar panel, or any other available source of power supply? That is what we call the backup time. It is in hours. Mr. Collins cannot say he wants it to run 4 hours, 5 hours, 6 hours, 12 hours. We will just take note of it. What you have to know as professionals is the higher the backup time, the higher the cost of running that system. Then we move ahead to the third parameter there, which is the budget. We will then ask Mr. Collins after we have assessed everything to see that okay, Mr. Collins is actually running on a large load. We will then ask him what is his budget for that project. Now, most installers shy away from these budget questions, and when they shy away from these budget questions, it will make them end up in trouble because after going through the rigorous step of system design, they find out that this client cannot even afford what he is trying to get. So, asking the question of budget when you have seen that what is to be done is much, we save you all the trouble, we save you all the stress. Then you ask what happens when your client budget cannot execute that project. You give him options. Your client should always be open to options. Yes, there's an amount of money which should be able to execute a specific size of system. Then you make provision for upgrades. It is that upgrade that will make you a better professional than an ordinary installer. I hope we are still together. All right. Importance of electrical load analysis. Importance of electrical load analysis. It ensures proper sizing of your system. It prevents overloading, prevent fire hazards, and improves safety and efficiency of your system. Okay, so now the big deal of the day. This is what we have been waiting for. So at this point in time, we will say again, this is the information you need. So you need to actually start writing from this point. And this is it is entirely free for now. So this information is entirely free for now. After now, it will no longer be free. So what you all are looking at, if you can see what I can see on my screen, is a typical example of electrical load analysis table. Remember we said electrical load analysis helps you to know the energy need of a facility. But then how do you do it? This table will tell us how we are to do it. Okay, this is a table we use. However, you can see the question marks and the total being unknown, which means that the information on this table is incomplete. So there are parameters we are missing, and that brings us to what we call parameters for electrical load analysis. Standard parameters for electrical load analysis. One, the quantity of appliance. Two, the power consumed by an appliance. Three, the running time of an appliance. Let's take them one after the other to have a proper understanding of what these things are. The quantity of appliance is a standard parameter which helps you to know the actual amount of the same appliance that is to be powered up using the solar system. Take for instance again our client for tonight, Mr. Collins, now asked us to run a solar system for him. And then we have seen that he lives in a three-bedroom apartment. In that three-bedroom apartment, he has a TV in each of those rooms. So if we are to power up two TVs out of that three, on our table of load analysis, what we'll be putting there will be two TVs. So it means that the quantity of TV to be powered, quantity of TVs placed to be powered up using the solar system would be two. That is what quantity of appliance simply mean or tells us. We have the one we call the power consumed by the appliance. This power consumed by the appliance tells you the rated wattages of each and every appliance that is to be powered up using the solar system. So how do you know the rated wattages? It is always gotten from the nameplate, which means the packaging or from the body of that your appliance. It is always written there. So what we call a nameplate. So you can get this information from the nameplate of each and every appliance. The nameplate contains the name of the maker, the name of the product, the country of make, serial number, IMEI number, um, what other information does it have? It has the current, voltage, frequency, wattage, which is the power consumption of that appliance. On my screen, you can see a typical example of an LG TV nameplate. Please, this is a little task for every one of us. I want you all to look at this TV critically. Can someone tell us the power consumption of this LG TV? In less than 1 minute. Can anyone tell us the power consumption of this LG TV? If you cannot see it properly, please zoom it in with your fingers, please. Zoom in your screen with your fingers for you to see it properly. Can anyone see the power consumption? Madam,
195 watts.
one, who is that?
195 watts. 195 watts.
Oh, thank you so much. 195 watts. That is very correct. Our lady engineer, Madam Fabian, are you here with us?
Yes, I can see it. It's
Okay,
195 watts.
195. All right. Thank you so much. Thank you. All right. So that is the energy consumption.
195.
Okay, thank you. So that is the energy consumption of this LG TV. So in case you go out there and you are faced with the challenge of getting this uh wattages, you just look at the back of that your TV, look at the back of the freezer, all the information that you need would be there staring at you. But then you must know how to read and interpret every nameplate. Yes. All right. So the running time of an appliance typically tells you how long those appliances are to be powered on. That is to say, the running time only takes effect when the appliances are turned on. That is when the running time takes effect. All right, so you can now see this is now the complete load analysis table. So you can now see the quantity of appliances appearing there, the power consumption is appearing there, and the running time is also appearing on this load analysis table as I can see it here right now. So now it is complete. Therefore, we have to do the system design to know the energy consumption of these five appliances. So Mr. David intends to power up the DVD player, the air conditioner, the ceiling fan, the refrigerator, the blender. Okay, so um, what do we do? How do we run a load analysis on these five appliances? How do we run a load analysis? Does anyone know? I don't think any of us know, including myself, because I'm also a beginner in all of this. So, how then do we do this? We have a formula which we use. That formula states that energy need is equal to quantity of appliance multiplied by the power consumed multiplied by the running time. The quantity of appliance multiplied by the power consumed multiplied by the running time. Quantity of appliance multiplied by the power consumed multiplied by the running time. That is the formula to use. And then how do you apply that formula? You you apply that formula such that you get the energy consumed by each of these appliances. Sum up the answers to give you the total energy consumption, which becomes the energy need of the facility. What that simply means is that you get the energy consumed by the DVD player, get the energy consumed by the air conditioner, get the energy consumed by the ceiling fan, get the energy consumed by the refrigerator, get the energy consumed by the blender, and then you add everything up to give you the total energy consumption, which then becomes your energy need of the facility. Now let us see how that works. For the DVD player, 6 multiplied by 50 by 1 gives you 300 watt hour. For the air conditioner, 2 multiplied by 1.5 times 2 gives you 4,476 watt hour. For the ceiling fan, 5 multiplied by 60 by 7 gives you 2,100 watt hour. And for the refrigerator, 3 multiplied by 100 by 5 gives you 1500 watt hour. For the blender, 1 multiplied by 1 5 by 1 gives you 1500 watt hour. So the total energy consumption becomes 9876 watt hour, and that becomes the total energy consumption, and that is the energy need of the facility. So you can now see from this table, the table is now complete. It now has the energy need of 9876 watt hour. Questions, please. All right. We can now take questions, please. Let's now take questions. So far, so good. Like we usually say, no question is useless, no question is meaningless. Um, or the what you can do is just to rephrase that question and it will make more meaning for us to have an answer. But if there are no questions, it simply means that everything has been gotten just the way it should be because it's a beginner course and we have made it such for beginners like myself and Mr. David, who is from Sierra Leone here with us. Mr. David, are you still here? Okay. All right. Like I said before, if you are having network connectivity issues, you may not need to worry so much because this class is being recorded. Miss Fabian, are you still with us? Is there any questions from your end?
I'm still with you, sir. No question for now, sir. No
No
question.
question?
Yes, sir.
Okay. All right. So now that there is no question from our female engineer and she has given us the go ahead, Miss Fabian, can we go ahead with the training?
Yes, you can go ahead, sir. You can go ahead.
Okay. All right. So if there are no questions, we just have one question for everyone before we proceed. Whether we get the answers right or not, we will definitely move on. All right, Mr. Nelson, our friend from Kenya, you are doing very well. So I have one problem here. Now, look at this table. This table says that the air conditioner is 1.5 horsepower. Now look at what we did for 1.5 horsepower that gave us 4,476. Our female engineer, do you have idea of how we got that? Every other value is in watts except that air conditioner which is in horsepower, 1.5 horsepower. Do you have idea of how we got 4,476?
Sir, maybe we have to convert that horsepower. We convert it to watt before we multiply it.
Perfect, perfect. That is good. So it means you actually know a lot of things in this field. All right, so we'll have to take it to the private session right now so that we don't teach others what we know. All right, thank you so much for answering that question. Yes, we need to firstly convert it to watt and then apply it in this formula for us to have that total wattage that we actually got. Thank you for that wonderful answer and contribution. But then the question that most of us will be asking, like myself, is how do you convert it? But then please don't tell us yet because it's not yet time for everyone to know it. Now, this is the point we tell everyone that it is now the end of the free training session and you are advised to enroll for the premium class to continue and complete the training course. Yes. So, in as much as you have learned a lot already, then you have not yet completed the class. All right, because at this point in time, you have just learned one part or one phase of the system designs, which is having to know the energy need of a facility. The complete part of it now tells you using that 9,876 watt hour to then size your inverter system, size your solar panel, size your battery system, size your what again, solar charge controllers. But then that is strictly for the paid trainees. Like our female engineer here, and a few others who are here too as well. All right. So, if you are yet to make your payment, like we usually say, it is you are going to put a full stop or a stop to your training till we receive your payment, and that is the reason why we advise you pay before the training commenced, so that you don't have to have this kind of pause or run helter skelter to make your payment. By now, some persons already know how much they have to pay. For Nigerians, you are to pay 5,000 naira. For Cameroonians, you are to pay 8,500 Cameroonian CFA. Ghanaians, 300 Ghana cedis. Um, Ugandans, 45,000 Ugandan shillings. South Africans, 350 rand. Zimbabweans 12 USD, Liberians 12 USD. Please, if you are here, you have not heard your payment amount, or you don't know the system to pay, please let us know right now, please. Questions on payments right now, please. Questions on payment only right now. If you are here, you don't know your payments, you don't know how much you are to pay or the payment system you are to use, please let us know before we wrap up for the night. We need to go right now, please. I hope you all can even hear me. All right. Okay. So, in the absence of no other question or questions, this is where we shall call it a day till the training holds again tomorrow for strictly paid students. So you have from now till the time the training will commence, same time it commenced today, for you to make your payment and then join the class. Please ensure you pay early. You can always text me privately for the payment details. We will send it to you so that you don't have to scroll on the platform. In as much as we are going to post it on the platform after this class, take your own payment method, make your payment, and then send in the evidence of payment on the training group, on the training platform for confirmations. Thank you all for being with us. Thank you for trusting in the process. See you all in the next training session. Have a wonderful night rest, everyone. Our female engineer, we would love to see you in the next class. Thank you so much. Bye bye.
Thank you. Bye bye.
Yeah, thank you.